Today's lesson is actually on surface area of cylinders and cones. In our last lesson, we talked about finding the surface area of prisms and pyramids. Today, we're focusing on two other polygons, specifically cylinders and cones. What's interesting about cylinders and cones is they both have circles involved with them, so they should be very similar to what we learned in our last class, but slightly different, just one slight adjustment. So before we learned that the surface area of a prism was going to be 2b plus pH. And we'll see this almost the exact same form when we talk about this today. So a cylinder, it's composed of, well, it's composed of not just one, but two circles and a rectangle. Two circles and a rectangle. So if you imagine having a cylinder and you were able to just like kind of cut off the top and cut off the bottom and make a slit down the side, you could actually unroll sort of this lateral area. You could unroll it and it would turn into this rectangle. This is the lateral surface. So if you were to take it apart, here would be one top, one bottom, and then you'd basically have this roll that's kind of looks something like this. So that's why it's two circles and one rectangle. So the measurements that we need to calculate the surface area of a cylinder are simply the radius, because that's what we're going to need in order to figure out the area of the circles. And then we're going to need to know the height of the cylinder, the height of the cylinder is technically the distance between the two circles. So this distance from the top to the bottom. Okay? Our formula for surface area is going to be very similar to what we talked about before. It says 2 times the area of a circle plus 2 pi r h. What this means is that we have basically 2 times the area of the base plus 2 pi r is basically the circumference, or very similar to the perimeter, times the height. These two formulas are practically the same, except this is specific for having two circles as your bases. Similarly, when we talk about a cone is basically one circle, not two, but one circle, and it has a rectangle kind of as its lateral face, kind of. And we have to get to that rectangle. It takes a little bit of work. So if we were to cut this piece apart, we definitely have this circle. That's pretty easy for everybody to see. And then if we were to slit this down the side, we'd have this sort of this fan shape. Well, what happens is you can take this fan shape and cut it into all sorts of little tiny triangles. And if you layer these, every other one, up and down, up and down, up and down, up and down, it actually forms a really, really, really nice rectangle. That's where the rectangle comes from. It's not directly a rectangle, but you can kind of turn it into a rectangle. The measurements that we're going to need to know here, again, the radius, so we can calculate the area of the circle. And then secondly, we'll need to know the slant height, which we also called the lateral height last time. Remember, that's if this was a mountain, kind of a cone-shaped mountain now, it'd be the area that you would slide down the side. It's going to be the lateral height. So our surface area formula, remember, for a pyramid was just B plus 1/2 PL. Okay? So if you remember, that was our formula, B plus 1/2 PL. Well, the B now, that's the base, that's pi r squared. And we have pi r L. Well, remember that circumference is basically 2 pi r, and we're just doing half of that, so that's going to be why it's pi r, and the L are the same. So this is our formula, pi r L plus pi r squared. And I'll see a lot of people write this as surface area equals pi r squared plus pi r L. It kind of has a nice rhyme to it if you say it several times, pi r squared plus pi r L, pi r squared plus pi r L. It's kind of easy to say. It's kind of nice to use. Let's see how these can be used. With this first picture, this is on the back side. For our first picture, always a good idea to write out your formula. So we notice that this is a cylinder, so that means we're going to use 2 pi r squared plus 2 pi r h. Again, this has a nice rhythm to it, 2 pi r squared plus 2 pi r h. We notice that it gives us the diameter. The diameter is 14, so I need to know that my radius is 7. That's going to be really useful for me. And then I just start substituting numbers. So that's 2 pi 7 squared plus 2 pi 7 times our height is 20. We put this in our calculators, we simply get 1187.5, and those would be square units. So 1170.5 square units. That's our surface area. For this one, it does give us our radius is 9 feet and our height is 7 feet. So if we have surface area equals 2 pi r squared plus 2 pi rh, we'll just substitute these in. 2 pi times 9 squared plus 2 pi 9 times 7. It's really nice to just be able to put in your calculator. Just type it in exactly how it says it, and you should get your answers. You should get 904.8 square feet. 904.8 square feet. Next, we'll look at two cones. The formula for a cone, again, this is S equals pi r squared plus pi rl. What we need is we need our radius, which is 3, and our slant height, this is an L, which is 8. So we'll just substitute this in. Pi times r, which is 3 squared, plus pi times 3 times 8. We can put it simply into our calculator, really easy, just exactly how it says. Some teachers will have you use 3.14. I just want you to use the pi button and just keep all your decimals that you need here. We should get 103.7. Since it doesn't tell us any units, we'll just say square units. Next, for this cone, again, it does give us the radius, but we have to be careful because sometimes it'll give us the diameter. We have to be careful with that. Surface area equals pi r squared plus pi rl. Our lateral height, or our slant height, is 10. We'll substitute in. That's pi times 5 squared plus pi times 5 times 10. We'll just write this in really easily here. We should get 235.6 square centimeters. Let's move on to something different. It says work backwards. This is just math teacher talk for, hey, I'm going to give you the surface area. You need to find one of these other lengths that we were given. Okay, so what we do here is we're given a cylinder. Remember, it has two bases that are circles, so that's what makes it a cylinder. So let's just write down the formula. Formula for a cylinder is 2 pi r squared plus 2 pi r h. We're given the surface area is 12,500, a very large number. That equals 2 times pi. My radius is 12.5 squared. And this would be plus 2 times pi times 12.5 times my height between my circles is actually x. I'm going to simplify this one step, just kind of in between. I'll take this 12.5 and I'll square it. I'll take the 2 and I'll multiply it by the pi. So when I do this, again, I still have my 12,500. That's going to equal 2 times pi times 12.5 squared. What that gives me is it gives me this number that's around 981.075, something like that. And I'm going to keep all these decimals. It keeps going for a while. Then I'm going to say 2 times pi times 12.5, and that's going to be some number like 78.5 x. And there again, there's some more decimals with that. I should probably just keep all those decimals. The first thing I'll do is I'll subtract this 981.75 number from both sides. 981.75. This is getting really sloppy. I apologize. 12,500 minus 981.75. That gives me somewhere around 11,518.25. That's going to equal to 78.5 times x. These are a little bit more complicated to work backwards than some of the other problems that we've worked. So you got to be really careful. Divide both sides by the 78.5, and hopefully you get somewhere around that x equals approximately 146. We'll just call it 146.7. Depending on how much you rounded, that's what you should probably get as your answer. If you kept all the decimals, you probably would have gotten 146.65 would have been probably where you rounded. Again, keep the centimeters when you go. For this next problem, if you don't have your calculator handy, I do want you to work this along with me just to make sure that you're able to get all the numbers. I think that's really, really, really important. So again, we have a cone, so we'll write the formula for a cone. That's going to be pi r squared plus pi rl. We'll substitute our surface area in, that's 368. It gives us our diameter. We really want the radius equal to 4. So when we say this is going to be pi times 4 squared plus pi times 4 times x is our lateral height. So we have 368 equals, this is 16 pi, plus this would be 4 pi x. The first thing I'll do is I'll subtract 16 pi from both sides, and that should give me a kind of a weird number, minus 16 pi. That gives me somewhere around 317.7, I don't know, 73 something, and I'll just keep all those digits in my calculator. That's going to equal 4 pi x. I'll just say divide both sides by 4 pi, and I can simply type that in my calculator using probably parentheses. I'll probably put parentheses around this, otherwise I might start multiplying some things. So I divide both sides by 4 pi, and I get that x equals approximately, we'll just say 25.3 inches will be our length of our x. Okay, so we are working with cylinders, we're working with cones, we're working with surface area of these shapes. So as we look through, I think it's really important for you to remember these two formulas that we talked about. Really, that for the surface area of a cone, it's just the base plus 1/2 PL. Here's your formula, pi r squared plus pi rl. And our other formula for this, really similar to 2b plus ph, it's 2 pi r squared plus 2 pi rh. If you haven't already done so, I think it's a good idea to add these to your note card. Make sure you have a really up-to-date note card. We could have a quiz pretty much any day. Just make sure that you are ready.